My privilege to speak with you, and I appreciate you spending the time to listen to the presentation today. And let's go ahead and get started. So the focus today is going to be on laying the groundwork for what is Elemental, what do we see as the trends in the entertainment industry, and how we can assist providers and others with meeting the needs of consumers as those needs change. So let's go ahead and get started. I'd like to spend a few minutes talking about those trends. If you look at the chart here, you'll see a stacked graph of viewing time by device and then divided by age group. So the green bar represents the traditional television device, and the others represent the devices that you see listed there: mobile and tablet and laptop and so on. And clearly there's a trend that younger people are spending less time in front of the TV screen. They prefer to watch their video on other devices. They prefer to watch it wherever they happen to be and not necessarily sitting on the sofa in the living room. And they also prefer to watch it on their own schedule. This isn't a lot of news to people, but it's interesting to see how age influences this. We fully expect that over time this graph will migrate basically to the right, and you'll see the upper age groups also spending less and less time in front of the TV set. And again, this is important because the providers of all this media need to be able to deliver it in the form that the viewer demands, and we see those demands changing, and changing fairly quickly, I might add. In addition to that, we also are tracking other values in the multi-screen world. So this chart shows a comparison between 2011 and 2015 in 6 different I'll say viewer values. So high definition quality continues to be the most important thing, but then you see other values such as the ability to perform time shifting. Surprising to me is that free from ads and commercials. I thought that would have been number 1, but it's not. It's about number 3. And then the ability to pick and choose what you view. The next category, video content anywhere, has shown the largest change over the 4 years. So specifically, it's increased 18 percentage points in that time. And again, this is the kind of thing that's super important for video providers, content owners, etc., to take into account, because this is what's going to drive whether you can reach your viewer or not. And 4K has a surprising amount of interest as well. So along these lines, and to describe another trend that we're seeing, the digital media and the processing of that media is migrating to the cloud. There's no doubt about it. Now, what might be the reasons for this? We have 6 that we've identified. These aren't necessarily in priority order, but pretty close. A lot of video providers want to swap capital expense for operational or variable expense, meaning they don't want to lay out a bunch of cash up front for a bunch of equipment and then amortize that over time. They'd rather pay as you go. And again, this is in line with what consumers want to do, right? They don't want to pay in advance. They want to pay for what they use when they use it. And video providers and broadcasters are no different. So that's trend 1, and cloud is a way to do that. Second, cloud offers the ability to scale pretty quickly. So, and you can benefit from the scaling that the cloud infrastructure offers, meaning that it's often less expensive, thanks to that economy of scale, to do things in the cloud than it would be to do them yourself with appliances in your own equipment room. And AWS obviously focuses on this, and scaling out to the point where that we can drop the cost. Very significantly, the cloud offers you the ability to not have to worry about capacity or guessing capacity. So ground-based appliance installations have to be provisioned for peak loads or close to peak loads. Otherwise, when you have that peak load, you're not going to be able to meet it. Well, that being the case, there's going to be other times when that equipment is underutilized. The cloud model instead just provisions as it goes and allows you to apply resources when they need to be applied and release them when they're no longer needed. And again, because everything in the cloud is pretty much already set up, you can improve time to market, run tests and proofs of concept at very low cost, and deliver new services in a much shorter amount of time than you would with the appliance or in-house approach. Cloud has global reach. You don't pay any extra to reach customers in South America than you do in Singapore or India, and the infrastructure there is available for you to use at any time without any additional charges. And then finally, we're in the business of broadcast, right? We broadcast, production, and delivery, all of those things to get video products out to the people that want to watch them. We're not in the business of building data centers, but as a auxiliary activity, it's something we must do if we are to maintain the video processing infrastructure in-house. Why not instead let the people who know how to build data centers build them and let us just use them? That's the message, and it allows the broadcaster or the video provider to focus on the media part of the business rather than on the IT or data center side of the business. Again, these trends are all real. These are actual reasons behind why video providers are moving to the cloud. Let's spend a few minutes talking about, what is this thing called Elemental. We like to think of ourselves as perfecting the media experience, and we're definitely the leading supplier of software-defined video solutions for multi-screen content delivery. I'm going to talk in more detail about what that software-defined thing is in a minute. But taking these high-profile Tier 1 channels and making them available across all manner of devices at massive scale is the thing that Elemental brings to the table. And we do it well, and these high-profile Tier 1 video providers, every one of them you see on the screen here, has placed their trust in Elemental to deliver their premium product to their demanding viewer. So some facts about the company. We've just celebrated 10 years since our founding. We delivered the industry's first massively parallel software-based transcoder using GPUs. Now that's that's a big mouthful. What that means is the job of encoding video is something that can be broken down into a lot of small pieces and then executed in parallel. And GPUs offer literally thousands of CPU cores that let a controlling software do just that, break the job down into many small pieces and then run them together. So we were the first to do that. Others have tried. They have improved their performance, but nobody has achieved the kind of density and performance that Elemental has. However, at the core, it's all still software. And this is what we mean by software-defined video processing. There's no ASIC, there's no FPGA, there's no DSP in the mix. And what this means is we can get to market a lot faster, and I'm going to provide some examples of that later, and we can adapt to changes in standards or practices or really demand much more quickly than if we had a hardware-based approach. The GPU is an acceleration tool. We can absolutely run without it. So we're a full software implementation of all of these video processing and coding technologies. Our headquarters are in Portland, Oregon. That's in the Pacific Northwest, the northwest part of the U.S. mainland. We have offices around the world, including Hong Kong, Singapore, Delhi, Sydney, and so on, Tokyo in Asia, Beijing, make sure I'm not leaving one out, as well as offices on the other continents, obviously. Our Asia headquarters is here in Hong Kong, but again, we've got offices across the region. We are now wholly owned by Amazon Web Services. That transaction closed October of 2015, so we're a year into this. I will talk more about how that's going later in the presentation. We have about 400 employees. When I joined in early 2013, we had about 100. So we've grown the employee base pretty quickly, and we continue to do so. This, in part, is assisted by the support we're getting from Amazon Web Services, which has been terrific. We continue to innovate in the software-defined video space, and I'll be talking about the innovations in various parts of this presentation. One of the facts of modern life in this media business is that video architectures are no longer the static 7-year build-out in your equipment room. They're elastic. Why? Because the demands of the viewer are so much broader now than they were 20 years ago, and they change a lot more often. So we have to be agile, we have to be elastic, we have to respond to these changes quickly, or we're going to be left behind. If you look at this chart or the drawing, you see the video sources on the left, the consumers of the video on the right, and then Elemental and AWS really taking care of everything in the middle. We'll be going through the products a little bit later on, but file-to-file transcoding, live stream transcoding, origin services, and so on, and CDN services, all in the mix, available from Elemental and AWS. One of the benefits of the software approach is this middle horizontal bar that says supported infrastructures. We can deploy on typical, Supermicro or HP or Dell appliances. We can deploy as in the cloud, and we do, or we can take a middle approach and deploy Elemental software solutions on customer-provided hardware in the form of virtual machines, or any two or any three. And we have customers, at either end of the spectrum, and some other customers using all three methods. There are components that interoperate in the whole video chain. We supply some, others come from third parties. So, for example, we're not in the content management business. We partner with content managers and DRM, digital rights managers, ad decisions, and so on, and they integrate their products with ours. We really believe that we have the most powerful video processing software in the market, the most, I'll say, complete solution. If you look at all of the things that the Elemental solutions do, they cover a broader area than any of the competitor does. And then if you combine that with the scalable cloud infrastructure provided by AWS, you have really an unbeatable combination. Additional AWS services are going to be integrated to allow delivery of really turnkey solutions, and then we're going to be enhancing cloud ingest solutions as well as service models, and watch for developments along all three lines in the next 6 to 12 months. In terms of customers, we have about 850 now. They are in 70 countries around the world, and they use a mix of our live and on-demand products, on-demand being the file-to-file transcoding. Everybody you see on this screen is an Elemental customer of one form or another, and you can see that these are, again, Tier 1 prime video providers, and you know, again, like I said earlier, have put their faith and trust in Elemental and continue to do so. In Asia Pacific, same story. By market segment, pay TV content, broadcast, and really other, again, Tier 1 have put their faith and trust in Elemental and do so every day. So many of these can be used as references, and you can check with them on their experience, and they will report that they're satisfied, happy, and productive using Elemental equipment. So where do these things fit? Let's look at sort of 5 market segments: content programmers, broadcasters, government, enterprise, and pay TV. I would add education to this as well. So really 6 of these things, and you know, all of those have viewers of one form or another that have to consume what they produce in terms of video, and they want to do so on all manner of devices, computer screens, game consoles, laptops, mobile phones, tablets, set-top boxes, and so on. And then obviously the job is get the content that they own out to those consumers, and that's where Elemental is an ideal fit. And we do that 24 hours a day, 7 days a week around the world. So let's look at the combination of these 2 companies, Elemental and Amazon. First, let's start with Elemental. We do have a broad suite of solutions that apply in this multi-screen space. Our biggest seller by far is Elemental Live. People love watching live video, and so providers love providing live video. And Elemental Live can be either used for events or 24/7 live streaming, and we have customers doing both. Again, taking a baseband or some sort of contribution level video signal, re-encoding it or encoding it, possibly encoding it multiple times to provide adaptive bitrate outputs, and then packaging and making it available to the delivery mechanism, usually a CDN. Elemental Server is actually Elemental's first product, and it's a transcoder that converts, again, mezzanine format video in the form of files to either adaptive bitrate or some other file format. And its claim to fame is its ability to do multiple things in the same time that other transcoders are able to do one thing. And again, this is from the parallel operation of the system. Elemental Delta is a relatively newer product. It's been out a couple of years, and we can think of this as origin services plus just-in-time packaging, add insertion, time delay, bitrate selection, and a host of other things that are useful to have in an origin server. We have, again, customers around the world using Elemental Delta as their origin server, and it's integrated nicely with the other products. StatMux, a broadcast-oriented product that does statistical multiplexing of incoming streams, combining them into a single multi-program transport stream at some fixed output bit rate and varying the allocation to the individual streams based on the video complexity. Conductor is the management station. It can handle management, single point of management for a multi-node, either live or server cluster, as well as redundancy management. So in a multi-node cluster, Conductor can be used move services from one system to another should something go wrong and there be a failure of some kind. And again, most of our customers, I dare say, use Elemental Conductor. All of these products are available in the cloud. All of these products are available as virtual machines, and all of these products are available as appliances. And that's what you see over on the right. We have customers doing, some customers using 2 or 3 of these deployment technologies. So for example, you can have a steady state file-to-file transcoder application based on appliances in your data center, but then if a peak event occurs or you have a library that you need to convert, you can overflow the processing into the cloud, get the peak demand satisfied, and then shut down the cloud and continue to use the appliance-based model for your steady-state processing. That's all built in. On the Amazon side, the media and entertainment building blocks that they offer are, as you see here. So for ingest, Amazon has a product called Direct Connect, which allows a dedicated connection, or essentially a dedicated connection from the ground instance into the cloud that guarantees a certain amount of video bandwidth. There are other technology or other products for bulk transfer of assets from one place to another, and then a transfer accelerator that improves the transfer rate to the Amazon storage. Compute EC2, this is the fundamental building block of Amazon Web Services, and all of, for example, the Elemental services are deployed on EC2, essentially a compute engine, a compute capacity, and we use instant types that are optimized for video and analytics. Processing, so Amazon has another transcoder called Elastic Transcoder. This is really designed more for low volume or maybe even one-off transcoding applications, very cost-effective, rapid, and available in the cloud. Storage, there's all manner of different storage pieces. The most common and probably the most cost-effective is S3. It offers scalable storage available online with good performance at a reasonable price. Glacier is a form of hierarchical storage that allows, say, assets that are accessed infrequently to be stored on very, very low-cost storage, but that will take some time to retrieve if they need to be retrieved. And then elastic block storage and so on for other high-performance applications. Delivery, I talked a bit about Elemental's origin services. Amazon has for some time now had a CDN, a content delivery network called CloudFront. It is literally changing the game. The competitors are having to alter their pricing models and other things in response to the uptake of CloudFront by customers, and that's growing by day. CloudFront's footprint around the world continues to grow, and it's used actually internally by Amazon as well as by external customers. And finally, analytics. For the big data people in the crowd, Amazon offers all kinds of analytics and tools for analyzing these captured metrics. So that's a quick look at the Amazon M&E building block collection. So I mentioned I mentioned earlier that Amazon bought Elemental in October 2015, and so why? Well, Amazon, let me back up a second. Elemental Cloud, the platform as a service that offers our product functionality in cloud, has been shipping since, or has been available since 2013. At the time, Elemental went through and evaluated the various cloud platforms that were available and chose Amazon based on a number of criteria: reliability, robustness, security, cost, a variety of things. And it became, very clear at the time that Amazon Web Services was the way to go. Well, at that time, of course, we had no knowledge that Amazon Web Services would be purchasing Elemental a short 2 years later, in 2015. They did, but our selection of Amazon Web Services as the platform for Elemental Cloud had absolutely nothing to do with that. That decision was made on the merits of the Amazon Web Services platform. It's certainly not open to much debate. Amazon Web Services is absolutely the world's most advanced cloud infrastructure. It has by far the largest capacity, by far the largest reach, the number of data centers, the number of instances, and so on. The focus in the company on security, scalability, reliability is singular. This is job one for AWS, and we're looking at 1 million customers in 190 countries. On the Elemental side, as we have seen, we bring pretty deep video processing expertise to the table. We can monetize, deliver content, provide the tools to monetize and deliver content. And as we saw earlier, there's 850 media leaders who use our products. The rationale is Amazon, among other things, wants to be video provider to the world, and they saw that Elemental is the way there. So that's really the rationale behind the acquisition. For Elemental, it's been great news because we get lots of good support and lots of really investment, as well as processes and other things we get to learn from the experience of Amazon Web Services. So together, the two companies, which is now one company, the combination give customers the ability to scale integrated platforms and solutions for the next generation of challenges. Okay, so what are approaches to solving these media problems on AWS? You can really divide it up into 3 broad categories, and the lines between these are not, sharp. They might be a little fuzzy, and there might be some overlap. But starting on the left, thinking about Elemental Media Solutions, in other words, focusing on the Elemental side of the business, we see the appliance and virtual machine on premises, or possibly the cloud-based approach in AWS. But you can stay really within the Elemental product line if you so choose. For more, shall I say, demanding or higher requirements, you can work through partners. They can find the third parties that are needed to fill out the design or the requirements. And examples that we talk about, Aspera here, which is a data transfer accelerator. You might want that for your particular workflow. So work through partner, work through Aspera. And then finally, you have the ability to just do it all yourself. We give you all the basic tools, interfaces, APIs. On the Amazon side, there's AMIs, Amazon Machine Images, available in the Amazon Marketplace that do all manner of things that might be interesting or required in various workflows. And then across the bottom there, you see the set of AWS services, mostly media focused, but for example, the relational database system, NoSQL, and Lambda which I'll talk a little bit more about Lambda, as well as many, many others available on the console. So I'd like to change now and spend some time talking about customer use cases and some reference architectures. So, back in the old days of, 3 years ago, using cloud for media workflows was pretty much unheard of. And there were a couple of pioneers in this, and we're going to talk about one in particular. So working backward from the display devices to the CDN, and then the actual deployment, taking a video source, encoding it as a VOD asset, and then delivering it. BBC really led that effort, or pioneered exploitation of the cloud to solve this problem. Jumping ahead to really the present time, but in the intervening years, as we'll see, live events are able to be handled by cloud processing. So, it's particularly ideal for that because live events generally have, a short lifetime, and so it can make great sense to deploy those on the cloud, because when you're done, you don't need to. You can, in effect, return the asset and no longer have to pay for it. Amazon itself has a product called Instant Video. This is something that came out, I want to say, a year ago, maybe a little less than a year ago. And it's taking some of the Tier 1 channels, like, for example, HBO, and making them available as individually purchasable channels through the Amazon Instant Video mechanism. So when Amazon decided to get into this, they dipped their toe in the water and they said, okay, we're going to use Elemental, and again, this was prior, the work on this started prior to the acquisition. We're going to use Elemental. We're going to make it highly reliable, highly robust, and highly available. And you can see some of the, I have a more detailed diagram later, but main and backup for everything, as well as deployment to CloudFront, as well as another CDN for backup. And then finally, there are live to VOD workflows implemented to our partner, the platform, that use our Origin Services product as well as the Amazon storage. All of this is real. All of this is done every day of the week in the cloud by various customers, which we're going to see shortly. So let's talk about that BBC. The BBC has a wonderful product that is loved by Brits around the world called iPlayer. And one of the things it offers is the ability to watch catch-up programming, meaning that a program that a viewer might have missed during the day, they can watch it, at night. Well, all of that programming needs to be encoded, packaged, stored, and then made available to potentially thousands. I think the BBC has established that they are directly supporting 1,000 different viewer types, phones, tablets, computers, and all that sort of thing. So that was the challenge. The other piece of the challenge that really isn't on here is do this without costing me a fortune. So the solution, because this is a spiky load, meaning that they wait till the end of the day and then they start transcoding the content and making it available. But in the middle of the night or in the morning, there isn't that the transcoding load is effectively zero. So it's great to use the cloud for this because I pay only for the services when I'm using them, and when I'm not, the meter isn't running. The other advantage to that is that if there's a special event, I think many of us are aware of the election in the U.S. or a sporting event or whatever, that perhaps there's more channels or more programming available, that spike can be absorbed by the cloud without the need for the customer to have any additional equipment. So the content is made available quickly. Changes can be made if new formats come into play, or new standards, new captions, whatever, and all of this can be adopted quickly. What does the workflow look like? VBC refers to this as their video factory, and it really is a template that others could use should they desire. The video factory captures the live, sends it for storage on S3 in the cloud. Then, as the assets are captured, the transcoders kick in and begin the transcoding, creating multiple adaptive bitrate streams, and then making it available to the CDN for delivery. And again, the cloud processing power varies according to the demand. The more work there is to do, the more nodes, if you will, the more processing power gets applied so that the job can be completed on time and the viewer can see his program. Okay, so now we're going to, I'm going to reverse, I'm going to go back one slide. This is an example of an everyday steady state use. It's spiky, as I said. The work tends to happen mostly at the end of the day, but it is something that happens every day. It's a process, and it's part of the everyday workings of the BBC. There are other cases, however, where we have a true event with a defined and likely very limited life. So we like to kid ourselves about the world's biggest sports event. I'm going to come back to that in a minute. Elemental has been a leader at ushering in this era of all digital sports experiences. By all digital, we mean file-based or stream-based encoded video signaling. This got its start way back for Elemental anyway, way back in 2011 with live streaming of the Pan American Games, the Rugby World Cup, and ESPN on demand. In 2012, we were heavily involved with the streaming of the London Summer Games, Stanford University near San Francisco, WWE, and Major League Baseball. That's the American Baseball League, the American baseball industry, if you will. They have infrastructure that's able to record essentially every detail of every major league game. So every pitch, every hit, every catch, every out, everything. And some of these are at that level of granularity. You have a video clip that's one pitch, or a video clip that's one catch. And they collect all this, and every night they process something like, I want to say, 10,000 video assets through the Elemental server, the file-to-file transcoder farm that they have in New York City, all under automation that they have written themselves. So moving on, in 2013, I was involved with this one, the world's first live 4K Ultra HD. Yes, that's redundant. The world's first live 4K HEVC transmission. The marathon race in Osaka, Japan, was captured or streamed live in 4K within Japan. And Elemental Live, the 4K version, was the product that was used to do this. It was quite, at first, in HEVC. And it was quite a milestone for the company. In 2014, the Winter Games from Sochi in Russia were also streamed using Elemental, and some of that was 4K as well. The World Cup, and then 4K broadcasts of the World Cup in 2014. 2015 brought us live streaming of what's called the Pacific 12 network, that the Pacific 12 Conference. That's a 12 universities along the U.S. West Coast that play each other in various sports, American-style football and basketball primarily. The Cricket World Cup, and then instant replays in a brand new American-style football stadium near San Francisco, the home of the San Francisco 49ers. The instant replays that the fans can see on the giant screen near the scoreboard and on the hundreds of other video screens inside the stadium. All that's handled with Elemental Live. And then we're going to talk about we'll talk about one of these shortly, but BT Sport has an Ultra HD channel, and it's the first live 4K in the UK, live sports 4K in the UK. Okay, so that kind of lays the groundwork for the next customer. Imagine that we have this large sporting event, which is the Olympics, and we have customers in all of these locations using Elemental equipment in one form or another to bring this biggest sports event to their customers, to their viewers without a hitch. And again, this is pretty important stuff, right? This is the Olympics probably has one of the largest audiences of any sport or other event, and Elemental's in the middle of it. So we've talked about this, software-defined video. Let's see how this helps to reduce complexity. Globosat is the leading broadcaster in Brazil, and we all know how Brazilians love their television, so this is very important that this be reliable and good quality. And their Globosat serves about 50 million, and they wanted to be sure that they could provide those 50 million viewers with a complete unified viewing experience across whatever devices the customer had. So as we'll see in the diagram on the next slide, but the signals come from the International Broadcast Center. This is a standard Olympic practice where there's a central broadcast center that everybody grabs signals from, known as IBC. It has nothing to do with the trade show. It was located, in the central in Rio, and then transmitted to the Globosat Broadcast Center, where it was then processed further for OTT delivery, as well as captured for VOD playback later. The software-defined video architecture allows support for SDI inputs today, and in the future we'll be able to support basically uncompressed over IP, the SMPTE 2022-6. And this was important in this case because they wanted that flexibility. Somewhat late in the planning, they realized there was going to be more demand than they were predicting earlier. As a result of that, they added 16 HD channels and 40 additional services. And again, they were able to do that because of the flexibility of the software solution. The OTT model looks something like this. Video sources in to Elemental Live, which then produces RTMP streams out to their own CDN. They're big enough to have their own. The CDN does the packaging, the encryption, the protection, and ultimately the delivery to the viewer's device. Off to the side, we have Elemental Conductor managing all this, and the control center is talking to the conductor through the network. So the Elemental kit is not at the control center, it's remote, and all of this was able to be done remotely. The VOD catch-up looks similar, not quite the same. Again, taking those inputs into Elemental Live, then segmenting or capturing the live and saving it as a VOD asset, and then pushing it out over the network to storage in another location. And then, again, it's not shown here, but the CDN would be involved when the viewer wants to watch a replay of some event or sport or play that they had heard about or seen earlier. And again, the control center is remote and is controlling the Elemental gear through our API and through our web user interface. The third dimension, of course, is the 4K. This is different because this didn't traverse the terrestrial network on its way to the viewer. Instead, Elemental Live was used to create a IP-based transport stream into a MUX and then pushed up to satellites for delivery to the viewer through satellite reception, through set-top boxes and various other devices. And again, the same kind of remote management where the management station was not in the same location as the control center. If you look at it all together, it looks like this. There's no new information here, but it shows the three prongs, the OTT across the top, the VOD workflow in the middle, and the 4K workflow at the bottom. Okay, so that's Globosat. There's another video provider in the country called Net Serviços. My Portuguese is very bad, sorry. They are a provider of pay TV and broadband, and they have deployed these hybrid IP-capable set-top boxes that can receive the sport channels that they provide. And they wanted, again, to provide the unified viewing experience, not only on the set-top box, but on whatever devices a customer might have. The 40 raw channels are sent to Embratel. They're transcoded, and using Elemental Live VM virtual machine deployment, so not the appliance, then Elemental Delta for packaging, encryption, and origin services, and then their own CDN to deliver to the set-top boxes and the multi-screen. An interesting twist in this application is this thing called AWS Lambda, which Lambda can be thought of as software that can be written and run but not require a specific instance of a computer underneath. It's this floating amorphous thing that just runs wherever it needs to run. And this company used that feature to drive our products to black out or replace content that was not allowed or inappropriate or unlicensed or whatever, according to the EPG, the Electronic Program Guide. We'll see that in the diagram on the next slide. Benefits: they got to deliver these 40 channels using the HLS, and then using DVB standards as well as IP for live and an experimental 4K, and then the viewers enjoyed the experience by all reports. The architecture of the workflow looks like this. Again, the signals came from Globosat, sent to this Embratel site, which was running the virtual machine instances. It then delivered transport streams to Delta, which did the HLS packaging, and then the CDN requested the assets from Delta as the viewers requested them. And this was live, so not file-based. This Lambda piece that I talked about earlier is in the dashed box at the bottom. So the Lambda scripts knew what the schedule was. They knew what programming had to be blacked out. When the time came, they sent the command to perform the blackout. The Delta would replace the video with a slate, or that would be done in live, and so the blackout would be accomplished, and at the end of the blackout period, a command was sent to come out of blackout, and that was all handled by software running in the AWS infrastructure. Okay, so one more. This is in a different country. This state-owned Uruguayan telecommunication wanted to bring live streaming of the Olympics to that population, to the people of Uruguay, where Globosat doesn't have a presence. And so Elemental is installed in their Tier 3 data center, and then live Delta Elemental server provided the Antel OTT TV offering, and as well as a mobile LTE-based offering. Benefit, again, bring the Olympics to the subscribers and scale based on additional services longer term. That workflow looks like this, again, from the encoders to 2 different sites, both with live capability as well as file-to-file delivery to the origin services, and then through a third-party CDN out to the devices. Okay, so that's a look at use cases. What can we learn from this? Well, about 3 or 4 things. We have a single software-defined video solution is solving all of these different scale of problems. So you can send, a single low bitrate rendition to mobile. You can send a super high quality, high bitrate 4K, and you do that all with the same software stack. I didn't mention earlier, but I'll mention it now. Elemental has written the entire stack. We own it, and we don't have to license codecs or other modules from third parties. The one exception to that is obviously for Dolby. That's something we do license from them, but everything else that is open standard like H.264 and HEVC, we might have to pay license fees, but we're not licensing software from any third party. Now, we didn't talk about this a lot, but as multi-screen becomes more popular, it makes sense for broadcasters to think about what we call unified headend. So you don't have a separate infrastructure for the OTT multi-screen piece different from the broadcast, main screen piece. We've had some customers do this with effective, simplifying operations and reducing cost. And the sophistication of the equipment and the interfaces and so on allow this kind of consolidation to happen, and customers are becoming more and more aware of the benefits of that. This SDV takes on the biggest challenges. Upcoming, we have more and more interest in cloud-based digital video recorders where the content is not sitting in the customer's living room on a drive or on a tape, heaven forbid, but in some storage in the cloud. And that's becoming more and more popular. Our solutions are deeply integrated with AWS services. Again, I mentioned earlier on that we chose them as the provider back when. So because they were the best at what they do. Okay, so one quick look at the how Elemental an AWS Power Today's Live TV. Specifically, the workflow you see here is what Amazon Instant Video has implemented. So in different AWS regions, main and backup live, main and backup Delta. This is how TV is being done these days, and the future is here. Okay, so that brings us to the end of the slide presentation.